There are somewhere between 100 and 400 billion stars in this galaxy, and the galaxy is 13 billion years old. At a tenth of the speed of light, slow by physics, hard by engineering, you could cross the whole 100,000 light-year width of it in about a million years. Against 13 billion, a million years is nothing. There has been time for someone to cross this galaxy end to end thousands of times over. And there is nothing. No signals, no probes, no engineering around other stars. That gap has about a dozen famous explanations, and almost all of them fail the same test, for the same reason. I'm going to show you the test, use it, and then give you the one answer that survives, which is not aliens are rare, and is not the one you've heard. Here is the test. Suppose there have been a million technological species in this galaxy's history. Now take an explanation like, they all decided not to explore. That has to be true a million times, not usually, every time, without one exception, across billions of years and a million separately evolved cultures. Because one exception, one species out of a million that does spread, produces exactly the galaxy we don't see. That's the uniformity problem. And once you're holding it, most of the famous answers fall apart in about 10 seconds each. The zoo hypothesis. They know we're here and they've agreed to leave us alone. That's a galactic non-interference treaty with no enforcement, no defectors, forever. Not one hobbyist, not one splinter group. They're already here, the UFO answer. Set aside the evidence problem for a second. Even granting visitors, it explains nothing else. Why the silence? Why no engineering anywhere? The dark forest. Everyone stays quiet because announcing yourself is suicide. This one is genuinely clever, and it still fails, but for a different reason. Hiding requires energy. Energy makes waste heat, and waste heat is thermodynamically impossible to hide. It has to radiate at infrared wavelengths we can survey. Dark Forest predicts a silent galaxy full of hidden industry. We see the silence, we don't see the industry. They're all sleeping. A real proposal from Oxford, and the physics is sound, computation gets cheaper as the universe cools, so a civilization that mainly wants to think would wait. But it needs every civilization to be patient, and dormant hardware still has to survive, which means infrastructure we should be able to see. 4 famous answers, 1 shared flaw. If an explanation needs a million independent species to make the identical choice, it isn't an explanation, it's a wish. Now, the ones that survive, because they don't ask anyone to choose anything. First, we have barely looked. In 2018, a group of astronomers tried to quantify how much of the search we've actually done. The search space has many dimensions: which stars, which frequencies, how sensitive, how long you listen, what kind of signal you assume. Their answer is the number worth remembering. The total volume of the search completed so far is comparable to scooping 1 hot tub of water out of Earth's oceans, finding no fish, and concluding the ocean is empty. It is very hard to be confused about an absence of signals when you have examined a rounding error's worth of the places a signal could be. Second, interstellar travel may be much harder than we assume. The problem isn't distance. At a tenth of light speed, every hydrogen atom in your path arrives with the energy of a particle accelerator, continuously for decades. Every dust grain is a nuclear-scale collision, and everything aboard has to keep working for centuries with no resupply. Robotic probes are easier, which is why self-replicating machines are the strong form of the paradox. But that means a machine that finds raw material in an alien system, refines it, and builds a working copy of itself, indefinitely, with errors accumulating every generation. We have never built anything close to that on Earth, with an atmosphere, a supply chain, and a workforce. Notice this one doesn't need uniform behavior, just uniform physics. That's a far more defensible claim. Third, the Great Filter. In 1996, the economist Robin Hanson pointed out that getting from dead chemistry to a galactic civilization requires passing a long series of steps. Life starting at all, complex cells, intelligence, technology, surviving technology.
The silence tells us at least one of those steps is nearly impassable. The question is whether it's behind us or in front of us. And this is the part that should stop you. Finding simple alien life would be bad news. It would mean the early steps are easy, which pushes the filter toward the part we haven't done yet.
So here's the answer I'd actually bet on. It's the most recent one, and almost nobody outside the field has heard it. It starts by changing the question. Not how many civilizations are there, but given that we exist, when should we expect to find ourselves? Think about what an expanding civilization does to a galaxy. It fills it. Once one appears on cosmic timescales, it converts everything reachable fast, which means a new civilization can only ever arise in a region nobody has reached yet. And the longer the universe runs, the less such space is left. So there's a deadline built into the structure of the universe. Late arrivals don't get to arise at all because their region is already claimed. Anyone who exists to ask this question must, by construction, have arrived early. Run the timing, and here's where we are. The universe is 13.8 billion years old. Stars will keep forming for trillions of years. We are inside the first 1% of the habitable era of this universe. Asking why the galaxy is empty right now is like showing up at a venue an hour before it opens and wondering where everyone is. This is the only answer that passes every test. It explains the whole silence, not a slice of it. No signals, no probes, no engineering, because there is nobody yet. It requires zero uniformity of behavior because it isn't about behavior at all. And it makes real predictions about how far away the nearest expanding civilization should be. It also flips the emotional weight of the whole question. If we're early, the silence isn't a warning. It's an opening. Everything is unclaimed. Two things to take with you. The first is a filter you can use for the rest of your life. Next time you hear the Fermi paradox discussed, listen for whether the answer requires 1 million independent species to make the same choice. Zoo hypothesis, dark forest, they all went quiet, they all went virtual. Every one of them needs that, and every one of them fails on it. The most repeated answers are the weakest ones, and popularity has kept them alive long past their expiry date. The second is that this stops being philosophy very soon. Every serious explanation here makes a prediction about biosignatures, and we are entering the decade where we can measure them. Telescopes operating right now can examine the atmospheres of rocky planets around small stars, and the next generation is being built specifically for this. If simple life turns out to be everywhere, the great filter is in front of us, and this becomes a much darker story. If even simple life is rare, then the filter is behind us. We already got through it, and the emptiness isn't a warning, it's an inheritance. Nobody knows which yet, but for the first time since Fermi asked the question over lunch in 1950, it has stopped being a thought experiment and become a measurement we're about to make. Next time, the machines we've already sent out of the solar system. One of them is still transmitting from over 20 billion kilometers away using less power than the light in your fridge. And what happens to them over the next billion years is far stranger than where they're going. Subscribe, and I'll see you there.